Okay, so today we're going to be talking about medians and altitudes. We've talked about mid segments, okay, and those are all kind of middle-y type things of triangles. And so in notes just a couple days ago, we did talk about a median. Okay, remember a median on a street is the middle of a street. So if you connect the midpoint of a side with the vertex across from it, you're going to find a median. Okay, and then if you do that to all of your sides of your triangle, okay, find midpoints of each side and connect it to the opposing side or vertex, then you will find the centroid is where all those will intersect. So point G is a centroid here. And then secondly, if you look at this, in any triangle, it doesn't form the midpoint of that segment AF. It'll actually be 2/3 of the way down the triangle, okay? So notice this side over here is going to be longer than the side right here, okay, that part of the segment. So in fact, if you look at AG, it's 2/3 of A to F, okay? And then also we could write a corresponding thing as well, is that G to F would equal 1/3 of AF. You see that? And so that's kind of cute to be like, okay, in this shape, 2/3 of it's going to be on one side and 1/3 will be on the bottom half, if you kind of consider the base the bottom. So same with CG. If you look at CG, that's 2/3 of CD. Well, then that means that GD will equal 1/3 of CD. Okay, so it's kind of good to write both of these things, okay? And then the other one would be, if you talk about BE, okay, from B to G is 2/3 of that length, okay? And then that means that GE will be 1/3, okay, of BE. Okay, so every one of those medians, okay, when you make them all, okay, where they meet at the centroid will divide each of those medians into a 2/3, 1/3 shape, okay? And so if you place it kind of facing this way, you know, where the median hits, the medians hit each other at that centroid, the top half will be longer, and that's 2/3 of the overall height, and this will be 1/3 of the overall height of that shape. Okay. And so, and it's not really the height, but that length. Okay. So it's not really the height because it's not necessarily perpendicular to that base. Okay. And so I shouldn't really call it a height. Heights must be perpendicular to the base. Okay. And so we will work with altitudes or heights next. Okay. So let's look at the next part we're talking about. The altitude is another type of a way of finding the middle, okay? And it's not really the middle, it's just gonna be perpendicular to the base. And so any triangle can be rotated and you can make the base perpendicular, or the base and the height perpendicular to each other from any perspective. So say that you've got a triangle that looks like, oopsie, hang on. Say that you've got a triangle that looks like this. Actually, it's not gonna draw. Okay, great. The height would be right here. It'd be perpendicular to that base. Now I could flip it on its tummy and rotate it and be like, okay, what if I draw it like this? Well, then this will be the base and the height will actually be outside the figure. Okay, it has to be perpendicular to the base. So we should do a delta math so you can practice finding the base and the height. Any way you twist a triangle, the base can be that bottom and the height will be perpendicular to it. So every triangle has 3 sides, so it could have 3 potential bases, and then the height will be drawn perpendicular to it. It's the overall height of the figure. So if this is the base down here, the height will be this part right here. It has to be perpendicular to that base. And so they call it an altitude. It's from the vertex of an angle perpendicular to the line containing the opposite side. So you may have to extend it a skosh to be like, hey, this is my height here, and it has to be perpendicular to this base right there. Okay, and so sometimes you have to extend the base. The length of the base is still from A to B, but you have to draw like an auxiliary, like dots to say, okay, if I extend the way that this looks, then the height will be perpendicular to that base. So if you wanted to find the area of the triangle, if this bottom was 3 and this height was 4, you would times 3 by 4 and divide by 2, okay? Because the area of a triangle is always base times height, and then divide by 2. And so you just have to extend the line of the base so that you can draw a perpendicular height that goes from that line up to the tippity top, the opposing vertex of that figure. In a right triangle, it's almost easier. It is. The base is that side, one of the legs, and the height will be another leg. So I really like to find the area of right triangles because the base and the height are the legs. Okay. Now, even on that one, we could rotate it and be like, okay, I want to put the base to be the hypotenuse, and so then the height would just be the distance from that opposing vertex to that hypotenuse. So as long as you have a right angle formed between the base that you're calling it the base and then the height that goes to that vertex, then you're going to be set. You'll have the altitude or the height, and they must be perpendicular, and it must show the height of the figure. So the base and height have to be perpendicular, and extend the base as you need to so you can make a right triangle to that opposing vertex, okay, to make the height. And then an orthocenter, okay, again, we're finding the middle parties, okay, of these parts of this stuff. So if you draw altitudes or heights from every single perspective of this triangle, so you can rotate your triangle as you need to. And so the height, again, has to be just perpendicular to the base, and it go to the opposing vertex. So you draw, if you draw the altitudes from every side, consider each side a base and draw the altitude to the opposing vertex. Where those meet is going to be called the orthocenter, okay? And notice, like on obtuse triangles, the orthocenter can be outside the figure, okay? It's a little weird to look at, but if you extend the base by a bit, okay, and you draw the altitude through it, you're going to get the altitude, okay? And so, let me see what we've got here. Let's look at our examples here, okay? Okay, so given CD is 21 and GE is 4, okay? So CD is 21. And so CD, it looks like, is this length from here to here. Okay, so that's 21. And then GE is 4. Let's see, GE is 4 right here. Okay, so that's 4. And that's 21. Okay, cool. So I think what we've got to think about is if these are going to be medians, then we've got the 2/3, 1/3 rule. Okay, and so we got to think about what do I know and what do I want to find. If I want to find CG, okay, and I know CD, okay, well, the relationship between CD and CG is going to be 2/3 of CD. Okay, so CG is equal to 2/3 of CD, okay? And so which one do we know? We know that CD is 21. So we're going to find CG, we're going to go CG is equal to 2/3 times CD, which is going to be 21. So if you take 2/3 times 21, I'm going to put it over 1, and I'm going to divide 3 into 21. I get 7 times 2 will give me 14. So this will be 14 units, okay? The next thing is we've got to find GE. Okay, so GE, oh, we know GE, sorry, we're supposed to find BE. Okay, so on the blue diagram, we know that the bottom part of this is going to be a 1/3 of BE. Okay, so GE, the bottom of this, is equal to 1/3 of EB. Okay, so that bottom part of that is going to equal 1/3 of the overall shape. And so what we know is GE, correct? And so if we plug in 4 equals 1/3, and we can call it X if we want to, okay? To solve that equation, we're going to multiply both sides by 3. And so if you multiply both sides by 3 to get rid of the 1/3, you're going to get X is equal to 12. Okay, so with any one of these shapes, the overall shape is equal to, or no, the top part is equal to 2/3 of the overall shape. The bottom part is equal to 1/3 of the overall length. Okay, so Depending what you're trying to find, you can do that. Let's look at number 2, okay? It asked us to find the coordinate for the center of balance. So like, how would I even, okay, the coordinate for the center of balance is going to be at the centroid. Okay, so we're going to find the centroid. The centroid is where each of those medians intersect. You're like, how would I even do that? Okay, and so I think the big thing is we can find the midpoint of any two segments, okay, of this, and then we join it with the vertex, okay, and you have to see where those will meet. Well, the truth is, can you tell where the midpoint is here? Okay, and the answer is, of course you can. It's halfway between those. You could also do the midpoint formula where you do 8 plus 6 over 2, and that's going to be at 7. Okay, actually I lied. Okay, first of all, this is a problem. This is not 8, 0, this is 0, 8. So let's fix this. Okay, reroute the ship. Okay, here we go. So reroute the ship. So that's written wrong. So let's find the midpoint between those 2 points. I was like, why is this turning out so silly? Okay, so you do 0 plus 6 and divide by 2. Okay, that would be 3. And then you do 8 plus 4 and divide by 2. It's 12 over 2, which is 6. So 3, 6 is going to be the midpoint. So that's 3, 6, okay? Okay. And if we would actually draw this, we would say, okay, the median would connect that point, the midpoint, with this right here, okay? Okay, and we're like, okay, awesome, okay. And then my question would be, how do we want to find the centroid? Well, we can find all 3 of them. And then we can also say there's going to be a 2/3, 1/3 relationship. Okay, it's going to be the orthocenter when we find the midpoint of here and connect it to this point, burp, 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 and then find the midpoint here and connect it up here. And then we could do this mathematically and figure out where it is. We also, however, know that the centroid is going to occur 2/3 away from this vertex and 1/3 away from the point on the segment. Okay, and so if this overall length, if we count this length, it's 1, 2, 3, 4, 5, 6. So that's 6. Okay, so if you take 6 times 2/3, okay, 2/3 of the way to 6 is going to be 4. So 4 would be here and 2 would be here. So we really know where the centroid is going to be. Okay, the centroid is going to be exactly at this point. And if we wanted to find the other midpoints, okay, I found them. Okay, this midpoint over here is 1.54. And we connect it over to this thing right here. Okay, the thing is, that's going to also have the same relationship where it's 2/3 on one side and 1/3 on the other side. And that is going to coincide with this piece right here. So we're kind of doing this like by looking at it and kind of doing some math. And so the centroid is going to be at the 0.34. Okay, so at the 0.34. Okay, and so we kind of did that slightly by looks, but also by some math as well. Okay. Okay, the next one says, can you think about the next question? It says, if ABC has vertices at 6, 6, 10, 12, and 8, 2, write the equation of the median from angle A. Okay, and so again, I think with graphing, and so let's draw like a quick little graph of this thing right here. Okay, so if you graph the 0.66, okay, and so you go right 6, 1, 2, 3, 4, 5, 6, and up 6 will be about here. Okay, so 6, 6. Okay, that's there. And that's A. And then if you go to 10, 12, so 6, 7, 8, 9, 10, 6, it's going to be B is going to be up here, 10, 12. And then 8, 2. Okay, so it's going to be down here, so that's C. So if you graph this triangle here, okay, the question is, can we find the median? Okay, the median is going to join the midpoint of any two segments with the opposing side. And so I think we need a point and we need a slope. Okay, and so to find the median of this, I am going to find the midpoint of this side right here. Okay. Could I find the midpoint of a difference? Yes. Okay. If I want to find the midpoint of BC, and then I'm going to connect it to A and be like, can I write the equation from A to that midpoint? And then that'll be fine. Okay. So the midpoint from B to C is if you add up those two values, so 10 plus 8 is 18, divided by 2 is 9. So this is going to be 9. And then 12 plus 2 is 14, divided by 2 is 7. So if I want to write the equation from A, which is 6, 6, to the 0.97, I can write the equation between any 2 points. So you just have to find the midpoint and connect it to the opposing vertex. And so to find the slope, I'm going to do 7 minus 6 over 9 minus 6, and I'm going to get 1/3. Okay, so my slope is 1/3. And then we just pick a point to write the equation. Okay, and so I'm going to do 6, 6. So I'm going to do y minus 6 equals 1/3, and then x minus 6. Distribute that through, and you're going to get y is equal to, and then add 6 to both sides. Y is equal to 1/3 x, and that's going to be minus 2. And then if you add 6 to both sides, it's going to be plus 4. And if we had real graph paper, we could check it and be like, okay, if I start at 4 and I go up 1/3, will that make this graph? And the answer is probably, that line should be starting at 4 and going up 1/3 would probably be the appropriate slope. Okay. So that's a weird question, but if you stick to your definitions of what are medians, okay, medians join the midpoint of a segment to the opposing vertex, well, then we can write the equation. Once we find the midpoint, which is pretty easy to find, you can write the equation of the line. Okay, last question would be number 4, okay. We have to write the equation of the altitude from angle K. Okay, so let's try this. Okay, so we're going to spot the points. J is at -4, 2. That's J. And then K is at -2, 6. That's K. And then L would be at 2, 2. Okay, so we've got to say, okay, given this triangle, can we find the altitude from K? Okay, so again, to draw an altitude, you take a side and make a right angle with that side, even if you have to extend it a skosh, and it has to go through the vertex across from it. And so in this case, we don't need to extend it, but the altitude or height is going to be this value right there. Wait a minute, that's pretty easy. What's the equation of that altitude? It's just x equals -2. Okay, it's just a vertical line. Okay, so we've got that. Write the equation from the altitude of angle J. You're like, curses upon, I know. Okay, so that means we have to draw it here. Okay, it's got to be a right angle to the opposing side. So through K is going to be that. So the question is, how are we going to do that? Okay, and so we need a point, we need the slope. Okay, so here we go. So if the slope of KL, so KL's slope, okay, not the measure of KL, but the slope of KL is going to be equal to, I'm going to calculate the slope of KL. It's going to be, slope, all right, slope. So the slope of KL, okay, and then we'll do the opposite reciprocal because we want it to be perpendicular to that line. So KL's slope is going to be 2 minus 6 over 2 minus -2. And so it's going to be -4 over 4, which is -1. So if you want to do the opposite reciprocal of that, you're going to get +1. So if we want to write the equation of this line here, it's got to go through J. So J's point, is going to be -4, 2, and the slope is going to be 1. So we're going to do y minus 2 equals 1, and then x plus 4. And your equation is y is equal to 1x, and that's 4, and then plus 6. And you can check it and be like, look at this. It is going to be 1x plus 6, okay? Absolutely. And then the last one says, solve the system of equations to find the orthocenter. Like, what are you even doing? Okay, the orthocenter is where all 3 of these go together and meet. So you can find the place where lines cross by graphing it, seeing where they cross, and we can tell where it is, can't we? We can also solve it algebraically using substitution or elimination. So the two lines we're trying to see where they cross are the line x equals -2 and the line x is equal to lies. Okay, rewind. Not x. And the other line that we found was y is equal to 1x plus 6. And we can do substitution. We know what x is, so you can put x into this function. So y is equal to 1 times -2 or -2 plus 6. So that means y is equal to 4. And so if we could look at the graph, we would see that the point is at -2, 4. So if you solve by graphing, if you solve by substitution, you substitute one equation into the other, which was not too hard. It was to be -2, 4. And so here we go. Thank you and have a good day.